Hello, my name is Mayra Martinez.
And I am Isamar Rosa. We both are students at the University of Puerto Rico at Mayagüez, but this summer we're working here at the University of Michigan.
We work in the Advanced Civil Engineering Material Research Laboratory under the mentorship of Dr. Victor Lee. The primary focus of our laboratory is to develop new applications for ECC. ECC stands for Engineering Cementitious Composite, which is also known as bendable concrete.
You might be wondering why we're playing with Legos. Well, this summer we set out to develop Lego-like blocks made out of ECC. By Lego-like, we mean that the blocks can be easily assembled, disassembled, and reconfigured to create new structures.
ECC and plastic have different mechanical properties, so it may not be feasible to construct Legos like this from ECC. Thus, the main focus of our research is to design and test a connection that could be as versatile as the Legos. We believe that this construction method has the potential to reduce carbon dioxide emissions, energy usage, and reduce landfill waste.
For our design, we were inspired by many things, including Japanese and Chinese wooden structures, furniture assembly, demountable concrete structures, and modular construction. We made various designs, and we settled on two to test this summer. Both of them were primarily inspired by the joints used in traditional wood construction. The first one is based on the lap joint, but has the addition of bolts to affix the pieces together. The second is a modified dovetail joint with a short neck providing resistance in tension.
To cast these specimens, we use a modified version of ECC, known as green ECC, since it incorporates industrial waste in its composition. This means it has a lower CO2 emissions and energy usage than conventional ECC. In addition, half of the samples were also reinforced with a steel mesh near the connection zone. We then test the samples by breaking them.
The bolted lap joint was tested in a 4-point flexure configuration, which simulated a uniform loading in mid-span. The failure occurred in the top specimen, and it originated near the bolts. In a continuous beam, it would have been highly conservative to estimate the flexure strength at the same value of the tensile strength, which is 4.7 megapascals. Both the unreinforced and reinforced connection perform well below this value, despite the doubling of the load capacity in the reinforced connection. Also, in a continuous beam, the failure would occur on the bottom, whereas in our model, because the bottom part acted as the stress concentrator, the failure occurred in the upper joint. The results indicate that the connection design tested is not efficient in regards to material use. In many instances, we could observe that the bottom piece was not engaged and it emerged from the test intact. A more desirable outcome would have both pieces sharing and resisting the applied load.
The modified dovetail joint was tested in tension. Failure mode was the same for both reinforced and unreinforced samples. Tensile cracks developed in the inner corner of the female element, while crushing occurred in the male element. Maximum load increased 30% with the incorporation of the steel reinforcement. Nevertheless, the tensile stress was also well below the material capacity. The low tensile capacity of both connections tested may be due to the absence of strain hardening behavior in the material, because of the accelerated curing implemented to conclude the research on time. Instead, the connection exhibited self-tensioning behavior, which limited the low carrying capacity of the connections.
Future work will focus on reducing or eliminating high stress concentration zones. For this, finite element analysis will be incorporated to improve decisions on the design phase of this project. Also, the geometry will be modified to induce failure that is closer to the value of the material capacity.
If you're interested to know more about the work done here in the Advanced Civil Engineering Materials Research Laboratory, go to the following website.
This research was made possible by the University of Michigan Summer Research Opportunities Program and the Michigan Space Grant Consortium.
Thanks for watching!